All right, today we're going to look at a couple of problems from section 1.4, limits involving infinity. And so here we see we have three limits. In each case, it's the same function, 1 over x minus 1, the rational function, or a rational function, I should say. And it's the limit as x approaches 1 from the left, right, and the limit as x approaches 1. So a couple of ways to look at this. One is from a graphical perspective, and I'm just going to sketch a graph here. We know what the graph of 1 over x looks like. This is just moved over 1, so we know we have a vertical asymptote at 1, and here would be one branch, and here would be the other. And so we can see that as x gets closer to 1 from the left side, our function values are getting closer and closer to negative infinity. So we have two choices here. We can write the limit as x approaches 1 from the left of f of x, so I'm going to call that, is negative infinity. Or we could say the limit as x approaches 1 from the left does not exist. They are both true. This gives you, the reader, a little bit more information. Another way to look at this, other than graphically, we want to approach 1 from the left. So that means we're numbers less than 1. So if we did 0.9 minus 1, 0.99 minus 1, 0.999 minus 1, you would see that this is 1 over negative 0.1, negative 0.01, negative 0.001. And with this number less than 1 in the denominator, the overall number is going to keep getting larger and larger and larger, but in the negative direction. And as this x value gets closer and closer to 1, you keep adding a 9, adding a 9. This number in the denominator gets bigger, the overall number gets, or smaller rather, I'm sorry, and then the overall number gets larger, but in the negative direction. And so for here, we can see that from the right side, as we get closer and closer to 1, the limit as x approaches 1 from the right would either be positive infinity or does not exist. Again, both are correct. The positive infinity gives, again, the reader a little bit more information. And finally, the limit as x approaches 1 of f of x, we would have to say does not exist, because from one side it goes to negative infinity, the other to positive infinity. So there's no way to write that here, the negative or positive, because it goes into two different directions. So we would just say does not exist. Okay, so that's one example involving infinity. Let's look at a couple of others. Here we have an example where the limit as x approaches infinity of a rational function. And so our strategy is to divide all terms by the highest power in the denominator, which happens to be an x cubed. So we would take the limit as x approaches infinity, and each term, and I'm going to really write this out more than we necessarily would, just so that you can see exactly what's going on here. And then the same in the denominator. We have a 2x squared over the x cubed. Okay, so what we have is a limit law that we're going to apply here. And that limit law is the limit as x approaches infinity of c over x to the r, or the limit as x approaches negative infinity over c over x to the r. And that is equal to 0, provided r is a positive rational number and c is any real number. So you can see that we have set up, in many of these cases, this limit law to be able to be applied here. Well, first off, here the x cubes divide out, right? We never cancel. And these would divide out. And so you would be left as the limit as x approaches infinity of just the constant 3, which would be 3. Here, this would be x over x cubed, so that would be left with an x squared. So notice we have the constant term over x squared, constant term over x to the r, where that r is a positive rational number. So that's going to be 0. Same here, applying that limit law. In the denominator, The x cubes divided out, so we're left with the limit as x approaches infinity of the constant term 6. So that's 6. Here, x squared divided by x cubed, we're left with an x to the first in the denominator. And one more time, we have a constant term over an x to the r. In this case, r is 1, so that would also be 0. So we're left with 3/6, or 1/2. Now that's applying limit laws. We know this was a multiple choice question and you weren't showing work, right? Because our degrees are the same. We know from our Algebra 2 days, the limit is just the ratio of the leading coefficients. So it's kind of our checks and balance of that, but this is how we would do this applying our limit laws. All right, one that gives people some issue sometimes is when we have a radical in the denominator, and again, the limit as x approaches here, negative infinity. Using our same strategy is dividing by the highest power in the denominator, but here, the highest power in the denominator is the square root of x squared. But again, as many times we do, we go back to our Algebra 2 days when we learned that this, by definition, is the absolute value of x, which we know is defined to be x for x values greater than or equal to 0, or the opposite of x for x is less than 0. Well, because we're approaching negative infinity, then we're actually looking at x values less than 0. So when we divide by the square root of x squared outside of the radical, we're going to divide by negative x. So what that looks like here is we have 3x divided by negative x plus 4 divided by negative x. And in our denominator, and again, I'm not doing the limit of each statement as we normally would. So here, right, we have x squared over x squared because we're dividing by the square root of x squared, but inside the radical, and the 2 over x squared. So again, we have x divided by x, which is 1. So we end up with a negative 1 in the denominator. It doesn't look like that got crossed out. There we go. They get divided out. So that limit is going to be negative 3. Again, applying that same limit law here, 4 over negative 1, that limit as x approaches negative infinity will be 0. In the denominator, x squared divided by x squared is 1. So we end up with the square root of 1 minus, and again, applying our limit laws, that will be 0. So this limit, negative 3 plus 0 over the square root of 1 minus 0 would be negative 3. And let's do one more. And this problem is going to be one in which we're given some conditions, and we want to sketch a graph. And so you can see here that we have limit statements going to positive and negative infinity, approaching 2 from the left, or negative 2 rather, from the left and the right, positive 3 from the left and the right, and some function values. All right, so for something like this, definitely want some graph paper. So hopefully we can see all of this. Okay, so first off, I've got some coordinates that I know, negative 4, and at 5 we have 0. So over here at negative 4 and at 5, right, we have 0. Actually, I left off one here. F of 0 was supposed to be 4. So f of 0 is 4. So we have that. Okay, so these first two limit statements tell us that as x approaches negative infinity and as x approaches positive infinity, the function values are getting closer and closer to 4. Excuse me. So that tells us about a horizontal asymptote. So I'm going to draw that horizontal asymptote in here at y equals 4. And one of the things that seems a little counterintuitive is that we have a horizontal asymptote going through a coordinate, but that's okay. We're allowed to do that. Here, we have the limit as x approaches negative 2 from the left is negative infinity, and negative 2 from the right is positive infinity. So that tells us that we're going to have a vertical asymptote at negative 2. So that's x equals negative 2. And then our next one is that the limit as x approaches 3 from the left and 3 from the right goes to infinity. So we know that we're going to have a vertical asymptote at x equals 3. So I'm going to put that in here. All right. And we know the great advice of Jiminy Cricket in Pinocchio talks about letting your asymptotes be your guide. And so we know that we have to be approaching 4 down here as x goes to negative infinity. So we know we're either going to be down here or up here. And we have to go through this point -4. So we're probably going to be down here. And then as we approach -2 from the left, we're going to go to negative infinity. So those pieces of information here, here, and here tells us that we're going to be here. We're going to go through -4, and we're going to come down here. And there is that portion of the graph. Okay, over here we know we're going through 0, 4. We know as we approach -2 from the positive or right side, we're going up to positive infinity. And as we approach +3 from the left side, we're also going up to positive infinity. So we know our graph will look like that. And then the last portion down here, we know we have the coordinate 5, 0. As we approach 3 from the right side, we're going to negative infinity. And then back over here, as we approach positive infinity, we're getting closer to 4. So putting all that together, we know our graph will look like that. So again, we're taking all of these characteristics and putting them onto this graph. All right, hope that helps. See you tomorrow.